Okay, today we are talking about operation properties, so different number properties. You've probably heard some of the terms that you're going to hear today before. But looking back, we are going to just look at each one of these expressions. When we talk about finding the value of each expression, that means we're solving. So with your tables, you should have already solved some of these problems. So I have 2 plus 3 plus 1. What is my value going to be? It should be 6. Good. Okay, then I have 9 times 2. The value is?
18.
Then I have 9 minus 3 plus 9 plus 2.
17.
Okay, so you work it left to right. 9 minus 3 is 6, plus 9 is 15, plus 2, y'all got 17, and then 12 divided by 3 is 4. Okay, the next part's pretty challenging. You had to come up with an expression that has a value of 24 using these 4 numbers, and you can use any of the operations: addition, subtraction, multiplication, and division. Did anybody come up with one that gives you 24? Yes.
9 times 3 minus 3.
So we did 9 times 3 minus 3. So 9 times 3 would be
27.
27 minus 3 equals 24. That one works. Is there another one we can do? You don't have to use them all.
9 plus 3 times 2.
9 plus 3 times 2. So I would, if I did that one works great. I just have to make sure I put the 9 plus 3 in parentheses, because otherwise I would have 9 plus 6, because with order of operations, you have to multiply first. So with that, I'm really glad you said that one, because that's one that was listed as an example in our book. And so I wanted to make sure that we are noticing and taking note that that will work as long as I have those parentheses. So great job. Yes, Jeb.
9 times 3 minus 2 minus 1.
Okay, so now we're just going to break down that 3. So if I did 9 times 3 minus 2 minus 1, that could work also. I could do 9 times 3 plus 3 minus 6. Okay, there's a lot of different options. We could go forever and ever, because there's usually more than one way to get to a solution. Okay, what we're going to do today is we are going to talk about several. Do you have a question?
I haven't. One of them.
There's a ton of solutions. There are so many. Like I said, we could go forever and ever. We could spend all class period giving different ways to get 24. There's a lot of different ways, but we got to keep going because we've got some new stuff that we got to talk about. Okay, so looking at the next part, we have on the next page all of our properties, and some of these you're probably familiar with. You've heard them before, but we're going to just review together what they mean. So commutative property, that means changing the order of the add-ins or the factors, but it doesn't change the sum or the product. So if I have a bunch of numbers that are being added together, I can add them in whatever order I want to. It doesn't matter how I add them, because I'm still going to get the same sum. Same thing for factors. If I have a list of factors that I'm multiplying together, it really doesn't matter the order that I multiply in, because I'm going to end up with the same product. Associative property is kind of similar. The only difference is you're changing the grouping of what I do first. So notice on that one, I have my addition one. I put parentheses around 2 plus 4 first. That tells me do this part first. But it's the same thing as if I were to do 4 plus 1 first and then add 2. You're going to get the same answer no matter what. It works for addition and multiplication. I have something else called the addition property of 0. So this might be one that you've heard of but forgot about. Commutative and associative are typically the most common that you hear. But the addition property of 0 is basically just when you add 0 to a number, that number stays the same. But similar to that, we have the multiplication property of 0 and 1. If I multiply a number by 0, it's always 0. And if I multiply a number by 1, it will stay the same. Then you have the distributive property. You guys saw a little bit of this in our bell ringer this week. So distributive property is when you have a number that you're going to multiply. It says multiplying a sum or a difference by a number is the same as multiplying each number in that sum or difference by the number and adding the products together. So notice right here how I have this expression, okay? That's like if I take 4 times 3, and then I'm going to add it to 4 times 1. So 4 times 3 is 12, plus 4 times 1 is 4, so 12 plus 4 is my solution, which would be 16, okay? Down here, you can do the same thing with subtraction. So 4 times 3 is 12 minus 4 times 1, which is 4, and that would be 8. Okay, so you're just distributing. I like to think of it like Oprah. Does anybody know who Oprah is?
Yep.
Oprah Winfrey. She used to, whenever she had a talk show back in the day, she would do her Oprah's favorite things, and she would be like, and you get a whatever. You get a car, you get a car, you get a car. This 4 is like, and you get a 4, you get a 4. You could add all these things. They all get a 4, okay? So that's what I like to think of when I think of distributive property is Oprah giving everybody one of these things in her audience. Okay, we're going to keep on moving. Down here it says complete the equation and identify the property. So on this, I have 9 times 15 is the same as 15 times what? What would my missing number be? 9. Okay, so if I don't have any grouping symbols and I'm just changing the order that they're listed in, what is that called? Looking at that chart that we just went over. Would that be commutative, associative, addition property, multiplication property, or distributive property? All I'm doing is changing the order. Commutative, very good. So I'm going to write commutative, and I'm going to actually abbreviate. Commutative property of multiplication. Okay, number 2, with your tables, decide what your missing number would be and decide what the property would be. So y'all talk about number 2. Figure out what that missing number would be and what property it would be.
And it's addition.
Commutative and associative properties technically the same thing.
Kind of, but associative has something that commutative doesn't. What do you notice? Associative has what in the problem? Grouping. So if it doesn't have any grouping symbols, then it has to be what property? Very good. Okay, so I heard a lot of the right answer. Your missing number is what?
32.
32, good. And because there's no grouping symbols, what do we name this property? What do we call it? Yes. Commutative property, but this time it's not of multiplication, it's of addition. Okay, number 3. Y'all try this one. Number 3. What would my missing number be? What would the property be? What's your missing number, guys? 145. Good. What's the property?
Distributive.
I've got mixed answers.
Commutative.
I hear a lot of commutative. Why would it be commutative? Because there's no grouping symbols.
Because it doesn't change.
It doesn't change. The only thing that's changing is
The way of the numbers.
the way the numbers are appearing. Okay, you're just listing the numbers in a different order. So, commutative property of addition again. Okay, number 4. What would this one be, though? This one's different. What does that equal? It equals 248. And what did you say it is?
Addition property of 0.
Addition property of 0. Yeah, because it's a plus sign, so it's the addition property of 0. Okay, now the next one. Woo, we got a lot of parentheses here. So immediately, looking up at my examples, I only have 2 properties that include parentheses. So I got to see which one it looks like. Okay, in my examples, I have the associative, which is the same numbers. I'm just grouping them differently. Same exact numbers, though. Associative. But I also have the distributive, where you have a number outside, you're multiplying, and then I also have some addition or subtraction inside the parentheses. So which one is this showing? It is showing the distributive property. Very good. Okay, so we know it's distributive property. Do we know what my missing number would be?
10.
It's Olivia's, thank you. Okay, so I have 3 times 10, and then I have, remember Oprah, you get a 3, you get a 3. So I have 3 times 10, but then I have 3 times what? 2, very good. Okay, and then number 6, I'm multiplying 1 times something to equal 17. What would that missing number be? 17, and that is what we call the identity, right, multiplication property of 1. Multiplication property of 1. Okay, how are we feeling so far?
Good.
Oh no!
Come on, Sadie.
That sounded like. Okay, guys, you have this chart. I'm gonna let you use this chart. You can use your book. This is your book to write in, so you can always take it home if you need that chart to reference, like on your practice page later. If you don't finish in class, you can use that. Okay, and I am hoping that you do. I hope that you do use it because it will help until you start feeling more confident with everything. Yes.
What does number 5 say?
Number 5 says distributive property. I abbreviated distributive and put DIST. Okay, looking at the distributive property only. Okay, we're going to practice distributive property. So it says use the distributive property to complete the equation. So I have 5 times 97. What I want to do here is I'm going to break my number apart. So distributive property is actually really cool because this is what I use to do mental math. So just like on that problem on your bell ringer, it was like number 1. I forget what the numbers were, but you had a 2-digit number times a single-digit number. So you can break apart your 2-digit number based on your 10s and your 1s. So how many 10s do I have?
9.
I have 9. So what does that equal? Equals 9. If I have 9 10s, that's 90, right? 9 10s is 90. If I have 7 1s, how much is that? Just 7. So you can pull apart your number and show me, okay, the value of the 9 is a 90. The value of the 7 is 7. So now I can distribute, and I can solve this sometimes mentally, but it helps me break it apart versus doing 97 times 5. Because 90 times 5, let's practice some number sense. Okay, pretend like the 0 isn't here for a minute. What's 9 times 5?
45.
45 plus that 0 makes 450. So what I'm doing is I'm taking 5 times 90. I know that this is 450. And then what is 5 times 7?
35.
35. So mental math, this is fantastic because I can break apart my number. It's a lot easier to do 90 times 5 to get 450, and then you're adding 35. So my sum is going to end up being, if I was looking for it, my total answer would end up being 485. It's not asking for that, but that's how it works. Okay. Number 8, I'm breaking this up so that I have what plus what. I already have this 7. This 7 is out here. Notice it's not at the beginning, it's at the end. Does it matter?
No.
It's just showing you that it can be written either way. The multiplication number could be in the front. It can also be at the end. You're still going to solve it the same way. Okay, so I'm breaking apart 83. So what goes in the middle? Claire, what do you think? 80 plus 3. And so the first part, I'm going to do 80 times 7. And I would add it to 3 times 7. Okay, now it says use a property to find the sum or a product. Identify the property that you used. So on this one, because I have all addition, this is not multiplying anything. So it can be easily confused with distributive property. But remember, the difference between distributive is the symbol should be a multiplication sign. If all of these symbols are the same and I just have a grouping symbol, what property would that be? There's only 2 properties that involve parentheses. What are they? Distributive and what? Associative, right. Okay, so associative property of what operation do I have?
Addition.
Addition. So it's the associative property of addition. And what's cool about associative property is it's allowing you to group your numbers differently. So 6 plus 27 in my head isn't super easy. Can I do it? Yes, I can do it. But it's not as easy as if I were to regroup and do 6 plus 4. Because we all know 6 plus 4 is what? 10. And then I can easily add 27, which is 37. Do you see how associative property makes it easy? You can move how you group numbers around so that you can do it in your head easily. The whole point of properties, number properties, is to help you with number sense and mental math. Okay? It's supposed to be able to make numbers and solving problems easier in your head. Okay, what about this next one? I have a number times 0. Jason.
0 and multiplication property.
Yep. Multiplication property of 0. Okay, you and your tables, I want you to try and match the following to the name of the property. Now remember, associative should have what? It stands out. Associative property always involves what? Parentheses. Distributive property also has parentheses. So I know that this option here is either going to be distributive or associative, and this is going to be the other. You shouldn't match it to anything else. Okay, you and your tables work together. See if y'all can figure out what goes to what. We're on the matching part. So y'all discuss, y'all talk about it. We're going to draw a line to the match. Class, city class?
Yes, city, yes.
Class, oh class.
Yes, oh, yes.
Okay, the first one, I have that peachy color. It's an addition symbol. So, okay, sorry, we'll continue. All right, so I have 27 plus 0 equals 27. That is not commutative. It is not associative. It is addition property of 0. Very good. So we should have a line going here. Okay, 13 times 0 equals 0. What is that? Good. Multiplication property of 0. What about 9 plus 14 is equal to 14 plus 9? What is that? Commutative property. Good. What about this next one? It's either associative or distributive. What is it? Very good. 28 times 1?
Multiplication property of 1.
Bingo. And then the last one? Very good. Okay, y'all are just rocking this. Awesome. Moving right along. You guys can go back to that word search. Anytime we're doing something and you and your group are waiting on others, you can go back and do the word search. Okay, our practice on the next page. Now this is giving us a visual. Does anybody know what this is called? Does anybody know what this graph is called? It has a very special name.
Bar graph.
It's not a bar graph. Yes?
Like a picture graph?
Very close.
Pictograph.
Pictograph. Bingo. Okay, it's a pictograph. So we have a pictograph. You're going to see this again in just a minute. But here's an example that's already completed. So what we're showing is we're showing lions, tigers, and cougars. A pictograph will always have a key, and it's going to tell you what something represents. So each paw print is representing 4 cats. Okay? So it says a sanctuary has 3 types of cats. Find the total number of large cats. Well, how do I do that? If I know each paw print represents 4, then I'm going to multiply that by 3. That's next to the lions.
Yeah.
I'm going to multiply that by 6, which represents tigers. I'm going to multiply it also by 4, and I'll have to do something special in a minute. But I have 4 holes. Okay? Notice how this is pointing to cougars. Okay, why did I do this? Why did I add 2 at the end? Because why? Because there's a half. And if I know that each full paw print equals 4, that means half a paw print equals 2. Very good. All right, so let's look at our own example that we're going to complete together. The sanctuary has 4 types of small cats this time. And a paw print still represents 4. But I have 4 cats that I'm comparing. So I want to find the total number of small cats. So we're going to set this up just like our example above. But I'm going to have 4, and I'm going to multiply it by how many? 1, 2, 3, 4, 5. And then I'm going to add it to how many lynx paw prints do I have? Count how many paw prints I have next to the word lynx. I have 4. Plus, how many whole paw prints do I have by the ocelot? 4. Plus, how many full paw prints by the caracal? 3. Okay, and this is only including the whole number of paw prints. So what am I going to have to do at the end?
There's a half.
There are halves, and that's what I'm talking about right now. So we've left off this half and this half because these are only representing the whole numbers here. I got to, add 2 or add 4 because a half plus another half is 4. So I've got to tack that on to the end. Okay, now I can distribute. 4 times 5 is 20 plus 4 times 4 is 16 plus 4 times 4 again is 16 again plus then I have 4 times 3, which is 12, and then I have this plus 4 at the end. Okay, so now I add it all together. Distributive property, Oprah. Oprah says, you get a 4 bobcat, you get a 4 lynx, you get a 4 ocelot, and you get a 4 carrot cow. And then I'm going to add the weird little half paws together. I'm just going to tack that on at the end. Okay, so now I've distributed it all. You can see how I color coded. 4 and 5 makes 20. 4 times 4 is 16. 4 times 4 is 16 again. 4 times 3 is 12. And then I tack on that 4. Now I just do what?
Add.
Combine it all together. Add it all up. Okay, so when I do that, I have 4 and 16. I'm going to do those first because if I add 4 to 16, that makes what? 20. So then I have this left that I haven't used. 20 plus 20 is 40. And then what's 16 plus 12? 28. And then 40 plus 28 is 68. Guys, this requires patience. Some of you like to rush and hurry through things. If you do, you're going to make a mistake. You've got to work thoroughly. You've got to be patient. You've got to take your time. Okay, let's look at the very last one. It says, conduct a survey to find the type and number of pets that each student in your class has. Organize the data in a pictograph. Then use a property to find the total number of pets. Okay, raise your hand if you have a dog. Okay, so this is representing students, okay? So let's count the hands that we see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what could we do? Each circle represents 2 pets. So how many circles would I do? 5, 2, 3, 4, 5 plus a half circle because I had 11. Raise your hand if you have a cat. 1, 2, 3, 4, 5. Okay, so how many, if I have 5 cats, how many circles if they're representing 2? 2 circles and then half a circle. We're representing students who have these pets. Okay, other pets that aren't a dog or a cat, raise your hand. 1, 2, 3, 4, 5. Hold on, hands are shooting up after. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many circles? If they 5. 1, 2, 3, 4, 5. Okay, so now I'm going to use this data. I want you guys to try this with your group. We've got our data collected. You're going to try and use a property to find the total number of pets. You've got some freedom on how you want to solve this, but with your tables, I want you to solve it together. And then we'll check it. Class, city, class?
Yes and yes.
Okay, so looking at our pictograph that we created, how many students had a dog? If each circle represents 2. 11, okay? We had 5 that had a cat and 10 that had something else. So what's a quick way I could do this? Yes.
Count by twos, but
Uh-huh.
I did all that up. I did 11 plus 5 plus 10, and then when I added it up, it got 26.
Okay, so I could do 10 plus 4, which is 14, plus 10, which is 24, and then 25, 26. Okay, anybody else do it differently? They counted by 2s for each one. So 5 times 2 was 10, 2 times 2 is 4, 2 times 5 is 10, 10 plus 10 plus 4 is 24, and then 25, 26.
I got 20.
There should be only 26.
I got 30.
Does everybody see how we get 26? Okay, All right, so we might have just miscounted. There should be 26 cuts based on our data that we collected.